Hello. Alright, so we'll be making the drivetrain for this time. I did some changes. I lowered this by 0.5 inches so that it stays within the height limit a little bit better and inspectors are happy. And then I dimensioned this tube to 20 inches because that makes numbers nice and whole. Besides that, we can probably just get started. I'll work on drivetrain and then we can move on to probably the elevator plus the elevator like carriage thing to this, and then we'll probably end up doing the manipulator last. I mean, yeah, I guess we can just get started. To start, we'll just probably make a plane here, like this top plane here, 1.75, and then this makes our tubes at the same length, at like the same spot as our like drive. And then we'll make a center point rectangle, and then we'll make it to here-ish. That's 30, and then we'll make this 26. That's a drive. And then we'll make, actually this should not be, I'm trolling a little bit. This should not be a construction line. We'll offset everything by an inch. That. And then I'll make my mirror lines now. You can also use just use the planes, but I like having mirror lines. It's easier to reference. 4.25, 4.25, 25 like that. So then we can just mirror this, then mirror this, then we have our tubes. And then we want to have some cross beams for support, so we'll do something like this. So this is another 2x1. And 3.5 I think is the right one. I have base sushi swerve up as well. This might use 4. I'll talk about base sushi swerve later. It's a project I'm working on, but I guess we can make this 4 instead. That should make things easier for us. And then we can mirror this and we have our tubes. And then we can use the extrude individual feature script to get all these tubes like this. And then tube converter, everything. We'll be utilizing the 1/8 inch wall thickness standard tube instead of the max tube here because mostly because of load times actually. The max tube kind of is awful for your load times because of all like the weird details. I mean, the holes are pretty bad, but are not as bad as max tube, so that's why we're settling on this. Then we'll get again our swerve modules in, so we'll get the derived, and then we'll do MK4i low poly, and then this is the low poly MK4i's that we'll be using as a reference module. And this will make our belly pan process as well as a lot of our modeling process a lot simpler. So for this initial one, we can just transform by make connectors here. Like this. And then we're just going to do some mirrors. And we have that. And then we'll derive a battery actually. yes, I do basically derive almost everything, which is a little bit different from most Onshape workflows. But I really like having the reference geometry. KiCad app? Question mark? KiCad app, please. It will work, I believe. Oh, it imported too. Okay. Alright, we have one. So while we're waiting, what we're gonna do is we're gonna move this battery over here, and then we'll make the belly pan. And then I want to add some holes for the rubber things, and then that way we can get wires through. Anyway, I'm gonna change the color of this to I don't know. That's good enough. And then while we're at it, I'm gonna change all the colors here to 35, 35, 35, because I like changing the colors to something pretty. Oh, yeah, 32, 32, 32 right there. Nice and pretty. Oh, I think the sketch broke. Oh, I did something funny. Okay. I'm not sure why it broke, but there you go. Yeah, so we'll transform the battery. What I'm gonna do, this is a little bit redundant, I'm gonna transform this to the edge of the drivetrain, then offset it. And the reason for this is I wanna assume for some amount of foam. And also a Velcro strap. So something like this, and then we'll get a standoff again. Shaft generator, up to face, we'll slash washer. Okay, we'll run the bolt and washer half-inch hex. I think we'll use rev rounded hex here because the other option is Vex, and I don't know if anyone wants to be picking Vex here. And then we can just choose this and offset to this one. And we have a vague battery holder here, which is good enough. I guess the next thing we can do is we can probably just work on the belly pan, I think now. I was gonna add the holes on the side, and I mean, I can actually do that. But it's nice to have the electrical and reference before I do that. But I mean, I'm going to put the PDH here, then the Rio here. And then I might change the feature library, the feature order later if I think the other way is better. I really couldn't tell you, I'm sorry. Anyway, here's the belly pan. We're running something really simple. It's hello? Just run something like this. Actually, I'll do something funky and I'll midpoint. Midpoint this. And then I'll constrain this to this. And that shouldn't make it equal, yeah. And then I'll make this 0.25 from the module. And then we'll mirror this whole segment here. And that gives us a general belly pan shape. Right, like this. Actually, I'll disable imprinting as well. And then of course I can add a triangle here. And then I can make this parallel to this. I'll make it 0.5. That's probably enough room. use the scissor tool here. This will just cut out all the random junk. Guys decided to break this. I don't know why it broke. Okay, anyway. So now we have like a belly pan, right? The next step is to basically model our like holes and stuff. So what I could do is I could model our holes by using the use tool and individually selecting it, but that sounds like a lot of work. So I'll just this is a slightly scuffed workflow, but we'll just do this. And we'll just linear pattern it until it works. And then I'll do the same over here. Is this parametric? Definitely not, but belly pans by nature are bad, and that is my excuse. But we have all the holes for a belly pan now. I did a little bit of spacing just because why not? We want to add like battery stuff, so we'll just we can basically just arbitrarily choose some locations. Make sure you midpoint the midpoint these though, because it's good, and that way we can get everything in line and then run this all on this. I'll double check if this was constrained. I tend to forget. It's probably good enough. Oh, I forgot to do something. Okay, so you don't actually need this full size, so actually that might break some stuff. Okay, so this belly pan was a bit overkill, and I could save a bit of material. So I'm just gonna actually just delete. I wonder how I can do this. I could like make this like 1. Alright, and then I'll just individually delete these. Like that. Actually, what I forgot to do is I needed to offset this entire thing a little bit in. And then we'll delete this. And then you want it basically 0.25 from the hole. And that keeps most of it like relatively sane. I'm just gonna turn this randomly and open up the whole thing. The only difference is now I'll use one less hole. But it looks a little bit emotionally better, so I call it, so I'd rather do it this way. 15. once we're done, we can just extrude everything out. Make it 1/8 inch. Edit the appearance so it's something pretty like blue. And then we'll fill little edges. 2.25. And that's just smoothing out the whole belly pan. I think what's next is we want to basically... Oh, I forgot to do that actually. While we're at it, look up the rev, like power distribution hub, and figure out the whole pattern. We'll get that PDH in. It's 4 inches by whatever, so center point, go down the line, 4.8 by 4 by 8.5. And the one thing I do love about Rev products is they have really nice wool patterns, so it's very nicely dimensioned. I like making a drawing or whatever. And it's all number 10 too, so... Well, I think it's number 10. Well, it's... yeah, it's 0.2... whatever that is. I'll make it 1032, and then I'll make it a 0.201, and then someone can figure it out later. I usually do 0.196 as like my 1032 hole close fit, because I don't really like the free fit. But this is probably fine. Yeah, that should model our PDH pretty well. And then just to be a little bit funnier, I'll go and model the PDH as well. Once MKCAD is bringing that up, I'll change the color to like something like that. And since we have it now on reference, we can go in and add the quote-unquote bearing holes. You can do this with just like hand tools, like it's not that hard. For the belly pan, you can use like Fabrics or Senkutsend to order it. So for this one, I'm just gonna be kind of arbitrary. I'm gonna be like, okay, so I want a hole like here, and then electrical probably want like a hole here. Maybe something like here as well. And then luckily, since this is all in theory in CAD, it'll just exist, but this can be adjusted much later if I decide, or if I discover that like something funny happens and I need to use this, right? But we can continue working through this. through all, merge scope both of these. Then we'll go through McMaster, and then we'll get this roper grommet thingy. And you can just kind of download it. So this is forbidden. I already downloaded it, so it's whatever. Okay. 1 second. Okay, I have imported it-ish. So now it exists. I'll throw in this in here, and then we'll also derive this. And I'll change this color also to something pretty. And I'll just transform it just so that I can see how it looks. And it looks cool. The other things that you do need to do is... Actually, I want to add mounting poles for Pigeon and the Rio, so I'll quickly do that. And for some reason, the Pigeon has like a really weird mounting pattern, so I'll have to look it up. Pigeon 2, kit content, mechanical specifications? Drawing? Mechanical drawings. Yeah, it's whatever the frick this is. I have no clue who tried making this and why they decided to make me suffer, but we have a pigeon. We can model this as a square. 1.140. Oh, I guess it's 1.140 by 1.140, so and what is the hole size? It's like a 440 hole, right? So it's like a number 4 clearance free. What is wrong with you, CTRE? Okay, anyway, that does not look right. Oh yeah, okay, there you go. And I did not update this. There you go. Electronics mounting. Use this as the angle reference. This set the origin as this, and then make the clock angle like 9 degrees, because why not? And then realize it's probably a bad idea later, but I think this is cool. I think this is most of drive. I guess you could do the battery lead. Like, we can fix the battery lead if we don't want to have it just like hanging there. Yeah, let's add that. So we get like the SB50 battery connector housing. And then we'll quickly make a This is a little bit redundant, but I guess you can make a 3D printed part as well, actually. Oh, okay. Actually, no. I mean, it would work. I want to have a little bit of material though. I'm gonna transform this over here. We have SP50 connector. And it's kind of floating there now. And then we'll make this. I could make it a rectangle. I mean, this is one of the ways to do it. I prefer doing the plate method, right? But I'll just do this because it's easier. I love Onshape. Look at this. You get the wait 15 seconds for something to load. Actually, I should probably do it like this. You can probably skip this whole like Anderson side quest. I'll put a timestamp for when you can probably skip to. But we had a PH fire last time because we did not do this, so I want to actually this is way too much work. I'm just gonna have people cope. And I could probably make it as a plate, and I do it in base sushi swerve like this. But I wanted to make it a 3D printed part, so yeah, this is a little bit too much work. I'm just gonna import everything and we'll disassemble it. So we go in here, we can just import parts to like this. Group and fix. Like everything is relative to the origin, nice and pretty. So you might be wondering, why did I not import the Robo Rio? And I have no actual answer for you, so it's a little unfortunate. All the grommets are in. And then this is a bad idea. I feel like I should have made the clock angle just a normal 0. What I might do though is I might move this a little bit. I might move the PDH a bit so I could get room for ballast. Because I know I'm gonna need like an amount of ballast at some point. Right, so I'll probably move it by like an inch. And that should give me about like a thing of steel here, then I can get a long steel bar on the back. I mean, yeah, here's the drivetrain. Yeah, I don't really have anything else to say. If you wanted to go on the side quest of making a battery connector, that's a little bit simpler. What you can do is we do import the SP50 connector. And we do the thing where we make the plane. We can use the gusset feature script instead. And this is a little bit overkill, but it's easier than making a 3D printed part because I'm bad at making 3D printed parts. But we can just and I'm gonna completely ignore this, by the way. This is just this is just a reference, like hole, so I could transform the SP50 connector. On shape, please. Thank you. Actually, it really does not like when you do that. And we can like move this around if the wire is too bendy. And no, I'm not going to be cutting the wire. That sounds like a lot of work. Yeah, and here's our drivetrain. It's like 37 minutes, but I did go on a side quest, but I mean, here it is. If you really wanted to do some like high quality part naming, we could like go down here and select all the parts that needed to be named like this, and then get the parametric part numbering feature script. And we can get some arbitrary numbering scheme. Let me find it. I have Sushi Squad runs our own like numbering system, but I don't remember what it is, so I need to pull it up. Part naming guidelines here. Yeah, so it's assembly acronym G1 suffix dash part number value 100 and custom, something like this, and then starting number. And everything is numbered. Yeah, that's it. I don't know why the Rio is in the hernia, but yeah. Here is Drivetrain. I'll quickly shift P to hide that connector. And I'll quickly rename this to Layout Sketch plus Drive.